So we are going to give another Leetcode contest, another virtual contest, which is going to be on Leetcode. So it is 6:52, and we will just do the random shuffle. Okay, so biweekly. Oh, I don't know which contest is this. You are given a string S where every two consecutive vertical bars are grouped into a pair. In another words, first and second make a pair, third and fourth make a pair. Return the number of stars in S, excluding the each pair. Okay, stars. Okay, I don't get it. Okay, then why don't we are counting? Oh, okay. Okay, so we are only. Array. 2, 0, 5. Done. Count unreachable pairs of node in a undirected graph. Okay, so we will first take the size of the edges. Now you are given the undirected graph with n nodes and 0 to n minus 1. The number of different nodes that are unreachable from each other. Number of pairs. Okay. Okay, so we just have to find the groups. I see. So vector find the adjoint of n for India equals to m plus I plus plus adjoint of edges of I comma 0 push underscore back edges of I comma 1 adjoint of edges of comma 1. Okay, so just we have to make, why are we doing this? Instead of we will make DSU. Okay. In private, vector of int parent comma size comma, yeah, that's all. And we will just DSU of int n. Okay, now we are going to get int find function int x. If parent of x not equals to x equals to parent of x equals to x. Okay, so now we are bool unite. I don't know. ds dot get size of. Okay, so answer will be true. How? Okay, so answer is 0, answer is 14. Yes, we should submit it. Okay. Hey, maximum ZER after operation. Where it is bitwise or what? Bitwise. No, it is like in one select any non-negative name. Yes or no, no, no. It is not try. Select any non-index I and then update the question answer and nums of i's or x. Okay, so which positions are ones? We will just add them like 8, 1 and 2. Yeah. Okay, so we have to just check the number of bits. When nums of it, okay, so 32 will be the enough. I think 30 should be also enough. Is this is oh god, this is very simple. Number of distinct roll sequences. Okay, so you are given an integer, you roll a fair 6 die 6 times. Distinct sequences of roll possible such that the following the greatest common divisor of any adjacent value in the sequence is equal to 1 and at least a gap of 2 rolls between equal valued rolls. If the value of the ith roll is equal to the jth roll, okay, gap of 2 rolls, okay. N should be okay, so it is 10 to the power. Okay, we have to find also take the modulo. Okay, so we will make the states of like index, how many rolls are done, then previous value and previous two value. Done. Only 6 I didn't do, then 1 to 6 are only possible. Then okay, so 1 plus 2 plus 3 equals dp of okay, and we will do like return version of 0 comma previous will be -1, previous will be -1, and dp will be the passes and the maximum will be the n. Okay, now we are going to write recursion Like we will do it long. Return answer mod anti inx and then anti previous to and the vector of anti ndp and the inx equals to n return n return answer it will be the one move number of moves. Okay, so for anti I equals to 1 to I less than equals to 6 I plus. Okay, so if the current move is 1, the CD of okay, I think this should be enough. Okay, what is this? Like unsigned integer overflow, but we are taking mod at every operation. So I don't think so. It should be that runtime error. Condition of unsigned offset overflow to okay, wait. We are just taking this, making it here. Maybe this could be the reason. Okay, one LL should be no should not be the reason, and long should also not be the reason. Still, okay, so the index shouldn't. What is the? Okay, wait. Answer plus equals to dp of this. Okay, so minus one, not the minus one, zero should also be zero, and the GCD should directly. Okay, so we can directly take this here also. Hmm. So index should be plus one and the I in the previous two. Sorry, here it will be the previous. Dun, 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 dun. Dun, dun. Dun, 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 glory come. Dun, 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 dun. Dun, dun, dun. Dun, 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 glory come. Okay, so I have taken all the like okay, assume left. Mm, for two ways, maximum 36 sequences, to which six are already eliminated. Then two same GCD pairs are eliminated, which is two and two. Okay, so assume no, bro. Like if it is greater than n, we will directly return one. No, it should be equal to one as we will just paste it. Index will be zero. Okay, so we will recursion it. One previous. Okay, okay. Done. 184 done. Okay, sorry. Should be the reason of. Yeah, easy peasy. Within half hour. Okay, so it was pretty easy. So I am just now giving you an overview of how I solved all the questions. Okay, so here it is given that we will okay, we will group a pair of first, second, third, fourth, fifth, sixth, and so on. So it will be pretty obvious that first and we will only check between first, then second, third. We will not have to check between these two. So when I first encounter first bar, I will XOR it with 1. So the up value will become up. If up becomes up and we will encounter a asterisk, so we will take answer plus, like we will exclude it because we are excluding between these. So we are excluding 1, we are excluding 2. Now we are getting encountered by another bar. So we will again observe equals to 1. Now value of XOR up will be 0. We will encounter this, so no changes as the up will value of up is 0. Now after this we are again getting bar, so the up value will become 1. After that it will be excluded, so only these two will be the answer. So I have done this only. Okay, so the second question is like count unreachable. Okay, wait. Count unreachable pairs of nodes in an undirected graph. In this question, it is saying that one group and another group pair number of pairs which are not reachable from each other. So the size of this into size of this will be the answer. But it can be the multiple. So we cannot directly multiply. We have to take inclusion exclusion principle. But instead of this, we are taking like the size of this group into n minus size of this group. So this group with any other groups will be multiplied and the answer will be added. And we are dividing it by 2 because it will be counted twice as first and second and first. So it is unordered pair, I think. So that's why I have divided by 2. So in this case, assume. So like we will go to 0. The size of is 4. So 4 multiplied by 7 minus 4, which is 3. So 12 will be the added plus 2 into 7 minus 2, which is 5, 10, 22. And 1 minus 7 minus 1, which is 6, which is 28. And 28 by 2 is 14, which is the given. So I am using disjoint set union to get the size of group. I have made this. You can learn it at CP algorithms. Okay, so this is very like if you have practiced bit manipulations, then you can directly see the. So maximum XOR after operations. Okay, it is given that you can update the nums of I to be equals to nums of I and nums of I XOR x, where you can choose any x. Any means any. So we have to find the maximum possible bitwise XOR with all elements. So assume like I want to XOR all elements, then I will be adding all the bits which are possible because I can choose any x. So if assume like 13, 1, 7, 40, 46 will be the 2, 8, 6. Now, the bit which are on are like 8 and 8, 4, 8, 4 and 1, then 1, then 1, 2, 2, 4, then 8, then 4 and 2. So like 1, 4, 8 are already on in this. So I will choose x equals to 0. So 148 will be the answer, and nums of I and nums of I should be equals to 13. So the first level will become 13. Now 1 is already present at n, and if I also take 1 here, then bitwise XOR will be the 0 and it will not be maximum. So I will take x equals to 1 here. So 1 XOR 1 will become 0, and 0 and nums of I will become also 0. Now 7. In this 1, 2 and 4 are present, and we already have 841. So we only need second bit. So what I will do is I will choose x equals to 5. So 7 or 5 will become 2, and 2 and 7 will become 2. So this will become 2. Now uh, 8. We already have 8 present, so I will take x equals to 8 and nums of i's or 8 will become 0. So overall it will become 0. We already present 4 and 2 bits, so I will also choose x equals to 6, which will result in 0. So the answer will be 13 or 2 will be the 15 will be the answer. So let's check. Okay, so can I do custom test case? Yes. 13, 1, 7, 8, 6. Okay, so answer will be 15 according to me. Yeah, it is 15, pretty obvious. Okay, so this is a good, not a good, like a standard equation. But okay, so what I have done is like you are given an integer here, you have to roll a fair dice 6 times. And sorry, six-sided dice with n times. So assume initially we have diced 0 times with previous value is 0 also, and previous 2 is also 0. Now we are going to take recursion. So what I am doing in recursion is like if the previous value is not same and also not the previous one also, and either previous equals to 0 or GCD of previous comma the current die roll is also 1, then we will add it. We will do until inx will become n. If it is reaching nth, then we will turn 1, and we are doing mod after every addition, so the number will not be overflow. And I think this is it for my side. Thank you guys.